Hello everyone, welcome back to the channel. So in the previous session, we have discussed about the preparation of potassium dichromate. How the potassium dichromate prepare ಮಾಡೋದ್ರ ಬಗ್ಗೆ ಹೇಳಿದ್ದೆ ನಾನು. Yes, how many steps involved there? There are 3 steps. Just we recall the preparations. First step what you have done. Okay, a finely powdered chromite ore is treated with the what? Treated with the aqueous sodium carbonate. Used as to sodium. Okay, sodium chromate Na2CrO4. And along with sodium chromate, what are the side product? Carbon dioxide gas is produced, so it escapes from the product mixture. Then there will be iron oxide, Fe2O3. Iron oxide is formed. So what we have done there, that sodium chromate is extracted with water. Okay, then further the sodium chromate is acidified with sulfuric acid. On acidification, what happens? There will be formation of, or you can say conversion of, sodium chromate is converted into sodium dichromate. Okay, Na2Cr2O7. A sodium chromate dichromate is formed. Then third step, what you have done, that sodium dichromate is treated with the calculated amount of potassium chloride. It leads to potassium dichromate K2Cr2O7. Right? So it's about briefly brief discussion about preparation of a potassium dichromate. Now in this session we are moving for the continuous part of the chapter, that is properties of potassium dichromate. Properties of a potassium dichromate. Yes. Then if I consider properties of potassium dichromate, first we consider the chemical properties. Right? Action of alkali means reaction with the bases, or I can say alkali. So we know that potassium dichromate when treated with bases, or I can say in basic medium, we know that in basic medium dichromate, okay, dichromate is converted into what? Is converted into chromate, right? So we can say here in action of alkali means whenever potassium dichromate is treated with the alkali, say bases like potassium hydroxide itself. So what happens? There will be formation of potassium chromate and water. Say dichromate, potassium dichromate when treated with the alkali, or you can say base, gives rise to potassium chromate K2CrO4 plus water. So in alkali, or I can say in basic medium, dichromate is converted into chromate. On the other hand, we also considered when treated with the acids like sulfuric acid, say in acidic medium, reverse. So reverse in the sense that potassium chromate when treated with the acids like sulfuric acid gives rise to potassium dichromate. So here I can say conversions. Say potassium dichromate, what is the physical nature? It's an orange red colored solution, orange red colored crystals. If I consider potassium dichromate, or if I consider ion itself, Cr2O7 2 minus dichromate ion, which is a orange red colored solution. When it is treated with the, okay, say in, if I consider the basic medium, so in basic medium what happens? Dichromate is converted into chromate. Yes, practically how we observe color change. So dichromate is a orange red colored solution when treated with the basic, or I can say when pH is increased, pH becomes greater than 7, or I can say when treated with bases, or I can say alkali, is converted into chromate. What is the characteristics of chromate ion? Which is a yellow colored solution. Means if color changes from orange red to yellow, okay, what it means? Dichromate is converted into chromate. This conversion takes place in what? It takes place in a basic medium. Okay. Well, on the other hand, what we said in acidic medium. So that is if pH, when pH of the solution is less than 1, in acidic medium, what happens? That yellow color of the solution changes to orange red color. Yellow color ಏನಾಗುತ್ತೆ, ಆರೆಂಜ್ ರೆಡ್ ಕಲರ್ ಆಗಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಕೆಮಿಕಲ್ ಏನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ? Chromate ion is converted into dichromate. So it is very important. That is interconversion of chromate and dichromate ion. Okay. Well, if I consider reaction of alkali, potassium dichromate is converted into potassium chromate in a alkaline medium, or I can say in basic medium. Okay. Well, Then coming to the action of concentrated sulfuric acid. So when potassium dichromate is treated with the sulfuric acid, again in cold condition, means at normal temperature, okay, at 25 degrees Celsius, what happens? Say when potassium dichromate is treated with sulfuric acid, say in cold means at room temperature, okay, at RT, it is at a room temperature, there will be formation of chromic oxide of a chromium, CrO3, okay, chromium oxide is formed, potassium persulfate is formed. So please remember the equation K2Cr2O7, okay, plus 2H2SO4 gives rise to 2CrO3 plus 2KHSO4 plus H2O. So in cold condition, what is the equation? Is the equation K2Cr2O7 reacts with sulfuric acid gives rise to chromium oxide CrO3 plus potassium persulfate 2KHSO4 plus H2O. But on heating the mixture means at high temperature, okay, if you heat it in cold condition, chromium oxide, potassium persulfate, water is produced. But on heating at higher temperature, what happens? When potassium dichromate is treated with that is action of sulfuric acid only, but at a higher temperature. So on heating, the product, or I can say the nature of product formed is totally different. So here on heating, what happens? There will be formation of potassium sulfate, chromium sulfate, water, and oxygen gas is liberated. So at room temperature, or you can say at cold condition, chromium oxide, potassium persulfate and water is formed. But at high temperature, there will be formation of potassium sulfate, okay, potassium sulfate, chromium sulfate, Cr2SO4 taken twice, water and oxygen. Okay, so means at higher temperature, as it releases oxygen, therefore it acts as a good oxidizing agent. Okay, yes. Then if you consider oxidizing properties, yes, we know that action on potassium iodide. So potassium dichromate oxidizes potassium iodide to iodine. Okay, potassium iodide to iodine, which means here I minus get oxidizes to I2. So half of I2 plus electron. So here potassium dichromate acts as a oxidizing agent and it oxidizes potassium iodide to iodine. So look at the reaction. So K2Cr2O7 plus H2SO4 plus Ki gives rise to K2SO4 potassium sulfate, chromium sulfate, iodine and water. Now if you consider balancing equation, so K2Cr2O7 plus 7H2SO4 plus 6Ki gives rise to 4K2SO4 plus Cr2 SO4 taken twice plus 3I2 plus H2O. Okay, that is 7H2O. So potassium, that is action on potassium iodide means say potassium dichromate oxidizes iodide, that is potassium iodide to iodine I2. Then second one, action of hydrogen sulfide. Hydrogen sulfide means HTS, that is here sulfide S2 minus. So here what happens again? That potassium dichromate oxidizes sulfide ion to sulfur, elemental sulfur, right? If you look at the equation, say potassium dichromate oxidizes sulfide to sulfur. So K2Cr2O7 plus 4H2SO4 plus 3H2S gives rise to K2SO4, okay, K2SO4 Cr2SO4 taken twice 3 sulfur plus 7H2O. Okay, then third one, action of sulfur dioxide, okay, SO2. So here potassium, okay, potassium dichromate oxidizes sulfur dioxide to sulfate. So equation Cr2O7 2 minus plus 3SO2 plus 2H plus gives rise to, okay, sulfate SO4 2 minus. Then the next characteristic, it is the action of ferrous sulfate. Ferrous sulfate means FeSO4. FeSO4. So ferrous sulfate here iron present in +2 state. So ferrous sulfate is converted into ferric sulfate Fe2SO4 taken twice. Here iron present in Fe3 plus, which means what I can say here, potassium dichromate oxidizes ferrous ion to ferric ion. ferric ion. Okay, yes, if you look at the equation, so K2Cr2O7 plus H2SO4 gives rise to K2SO4 Cr2SO4 taken twice plus H2O plus nascent oxygen. Then if you look at the balancing equation, so 4H2SO4 4O2 plus 3 oxygen. Then on the other end, ferrous to Fe2 plus 2, okay, Fe2 plus converted into Fe3 plus, how many electrons are liberated? An electron, one electron is liberated here. So 6 FeSO4, okay, 6 FeSO4 ferrous sulfate plus 3 H2SO4 plus 3 oxygen gives rise to, okay, 3 Fe2SO4 taken twice, ferric sulfate. Ferrous sulfate is converted into ferric sulfate plus 3 H2O. So if you consider the net equation, okay, so the net equation K2Cr2O7 plus H2SO4 plus FeSO4 gives rise to K2SO4 Cr2SO4 take twice, Fe2SO4 taken twice plus H2O. Then if you think of balancing equation, so K2Cr2O7, how many sulfuric acid? 4 plus 3, 7 H2SO4, then 6 FeSO4. Whatever the oxygen liberated in the first half of the equation will be consumed here, so cancels. So 6 FeSO4, these are the reactants, gives rise to, say, K2SO4, then Cr2SO4 taken twice, then, okay, Fe, okay, Fe2SO4 taken twice plus H2O. So here 3 Fe2SO4 taken twice, 4 plus 3, that is 7 H2O. It is action of ferrous sulfate, means here potassium dichromate oxidizes ferrous sulfate to ferric sulfate. So remember the equation, right? Well, then coming to the again further oxidizing properties chart, that is action on primary and secondary alcohols. So again here also that potassium dichromate simply act as an oxidizing agent. So here if I consider, okay, ethanol CH3 CH2OH, okay, it is a what it is, it is a primary alcohol, primary alcohol. So primary alcohol on oxidizing, okay, when treated with potassium dichromate, it oxidizes, okay, alcohol to aldehyde CH3CHO. Primary alcohols are, okay, primary alcohol, it is alcohol on treating with potassium dichromate, that is primary alcohol, get oxidized to what? Aldehyde CH3CHO, okay, acetaldehyde. So generally I will say aldehyde. So primary alcohols are oxidized to aldehyde. So equation CH3CH2OH plus O gives rise to CH3CHO plus H2O. Then I will go for one more example, that is secondary alcohol. It is CH3CHOH, okay, CH3 2 propane 2 all, or I can say, okay, what is the name, propane 2 all, means here the second carbon there is a OH group, means it's a secondary carbon, okay, secondary carbon where the OH group is attached, therefore I can say it is a secondary alcohol. So generally what I can say, it is a secondary alcohol, right? So secondary alcohol when treated with the oxidizing agent like what, potassium dichromate, so that is secondary alcohol when treated with potassium dichromate, they get oxidized to, look at the product here, CH3COCH3, okay, what it is, it is a ketone, okay, okay, it is a ketone, ketonic group is there, that is C double bond O, so is an example of a ketone. Yes, which means what I can see here, primary alcohols are oxidized to aldehydes, while secondary alcohols are get oxidized to what? Ketones. Please remember this. In general, yes, potassium dichromate even shows oxidizing nature on primary as well as secondary alcohols. Okay, primary alcohols are oxidized to aldehyde, while secondary alcohols are oxidized to ketones. Okay, well, Then if you consider CH3CHO, acetaldehyde on oxidation gives rise to acetic acid. That is, aldehydes are further oxidized to carboxylic acids. Okay, CH3CHO, CH3COOH, that is acetic acid, means here aldehydes are further oxidized to carboxylic acids in general. Please, with respect to alcohols, primary alcohols are oxidized to aldehyde, then further oxidized to carboxylic acids. Secondary alcohols are oxidized to ketes. Well, then formation of chromyl chloride. So is the one more okay property of a potassium dichromate. Say here, when potassium dichromate is treated with the aqueous sodium chloride in presence of sulfuric acid, there will be formation of what? Yes, there will be formation of potassium persulfate, KHSO4, sodium persulfate, potassium persulfate, sodium persulfate, and chromyl chloride, CrO2Cl2. A chromyl chloride is formed plus water. So is the equation. Then coming to the uses of potassium dichromate. Well, in the manufacture of pigments and in the manufacture of inks, this potassium dichromate is used because of its color. As we have seen, chromate and dichromate, they are going to exhibit different colors. Therefore, potassium dichromate, which is used in the manufacture of pigments and even in the manufacture of inks, is the first use. Second one, the solution of potassium dichromate in concentrated sulfuric acid, there will be formation of what? There will be formation of a chromic acid. So when potassium dichromate is mixed with concentrated sulfuric acid, that resultant solution contains chromic acid, H2Cr2O7, chromic acid, which is used to prepare glasswares. Okay, yes, is the one more use. Then next one, in the manufacture of chromium compounds such as lead chromate and chromalum, potassium dichromate is used, is the one more use. The next one, as oxidizing agent, used in various reactions as a oxidizing agent, and in dyeing, okay, in dye industry, and even in the tanning of leather, okay, leather tanning, potassium dichromate is used. Then it is used as a primary standard in the volumetric analysis. So potassium dichromate, as it is available in its purest form, okay, that potassium dichromate can be isolated or can be prepared in its purest form. Therefore, it is used as a primary standard in the volumetric analysis, that is titration for the determination of ferrous ammonium sulfate and even iodine. Okay, well, then used in the detection of chloride ion by chromyl chloride test. In chromyl chloride test, yes, the potassium dichromate is used, is one more use of a potassium dichromate, right? Okay, coming to the MCQs. The first one, solution of potassium dichromate in concentrated sulfuric acid is called. So solution of potassium dichromate in a concentrated sulfuric acid is called a tanning solution, primary standard, chromic acid, none of the above. Yes, what it is? It is the chromic acid. So when potassium dichromate is added to concentrated sulfuric acid, that resultant solution contains chromic acid, so called chromic acid. So option C is correct. Then next one, secondary alcohol with acidified potassium dichromate solution gives. So that is when secondary alcohols are treated with the acidified potassium dichromate. What is the product formed? Aldehyde, ketone, anhydride, esters. Yes, what is the answer here? Ketones, right? So primary alcohol gives aldehyde while secondary alcohol gives ketones, right? Then coming to the next question. Complete the following reaction: Na2Cr2O7 plus 2KCl. That is the second step of preparation of potassium dichromate. So what are the product here? Look at the options. First option, NaCl plus Cr2Cl plus KNO3 plus O2. There is no case of KNO3, so it is wrong, right? Then K2Cr2O7 plus NaCl. Yes, it is correct. Then we go for other options also. KOH plus MnO4, wrong. Then none of the above. Yes, what is the correct one? Second is the correct. K2Cr2O7, that is sodium dichromate is converted into potassium dichromate. Okay, well, the next one. what is the action of alkali on calcium dichromate? That is in acidic medium, what happens? So option A, K2Cr2O7 plus H2SO4 gives rise to hot condition. K2SO4 plus Cr2SO4 taken twice plus H2O plus O2. Is it so? No. They said alkali, but they are writing equations with acids, so it is wrong. Then second, again sulfuric acid is written. Whatever it is, that equation is wrong, right? It won't use the action of alkali. Instead, they are specifying action of what? Acids. Then option C. Then what is option C? K2Cr2O7 plus 2 KOH. Well, gives rise to 2 K2CrO4 plus H2O. Yes, here in this equation they are specifying alkali. So well, we look for fourth option also. Then fourth one, K2Cr2O7 plus 2 NaOH gives rise to Na2CrO4 plus H2O. So yes, what is the answer? Option C is correct, right? Well, next one, balance the following equation. K2Cr2O7 plus dash H2SO4 plus dash H2S gives rise to K2SO4 plus Cr2SO4 taken twice plus dash S plus dash H2O. We have to fill the number here, right? Yes. First we look at the options. 4337, 4227, 4226 and 5336. Now if you think of balancing equation, the number of atoms must be equal on either side of a equation, that is reactant and product side. So now when you look at all the number of elements on either side of equation by placing 4337, yes, it is equal, right? So option A is correct here. Well, so with this I'm going to conclude about this session. Again in the next session we go for other concept. Thank you. Be safe.